Once again, welcome to Genesis Mathematical Institute. So today we will be looking at differentiation, but we will be looking at an aspect of differentiation. However, we're going to still look at differentiation in its entirety. So by definition, we are trying to differentiate to define what differentiation is, because we will have to start by definition before we now look at the types of differentiation. There are many of them, and we'll begin to pick them one after the other. I want you to subscribe to this video so that you have to subscribe so that you're able to follow the details of the teaching as we make progress in it. Ask your questions and comments. They will be all be welcome. Differentiation is the process of finding the differential coefficient of a given function. The concept there is differential coefficient, and then we have the function. Don't bother about much about the differential, but we have to define it by practical calculation. And that's to say that we are trying to find the change in a variable with respect to another variable. For example, now we want to find the change in y of x in respect to y. So in this case, we have two variables we are dealing with. One is called the dependent variable, and the other is called the independent variable. And so, as a matter of law, most times I want to give us the rules that guide this concept of differentiation. Number one is that the differential coefficient of a variable with respect to itself is always unit. That's to say that the differential coefficient of a letter like x is equal to 1, z is equal to 1, k is equal to 1, w is equal to 1, b is equal to 1. So the differential coefficient of any letter at all, any variable at all, is unit. That's number one. Then number two principle, we have to bear this in mind. Problems in this line. Number two is that the differential coefficient of a constant is 0. The second principle, just take note of this, that the differential coefficient of any constant is 0. Constant could be each, could be 1 is a constant, 25 is a constant, 1, 2, 3 is a constant, 70 is a constant, 80 is. So it means that the differential coefficient of these ones is equal to 0. Any constant at all, the differential coefficient is 0. So what we are dealing with here is that we are trying to find the differential coefficient of a variable in respect to another. So two variables are involved here. We have the y and the x variable. So if we have y is equal to x, so we want to differentiate y with respect to x. This is called the dependent variable. This is dependent. Y is dependent variable, and x is the independent variable. So what we simply mean in this case is that the value of y depends on x, right? So it is x that determines what the value of y is. So if x is 3, you know what the value of y will be. This is dependent, and this is what? And this is the root variable. That's why we are differentiating whatever we are differentiating in respect to x. So x is the base variable for our differentiation. So with this, we will now see the types of differentiation, and then we'll begin to pick them one after the other. First of all, with general rule, we will see it. So you can have a clearer view of what we just did on the board. So that is the enlargement of it. Y is equal to x, and equal. I know you have also penned down the definition itself. It's clearer now. To begin to solve more problems by the time we get to the next video.